Hello everyone. In this video, we will talk about data thief and basic of cryptography. There are 5 objectives to learn today. The first thing is to understand what internet eavesdropping is. Then we will see a demo of capturing unencrypted traffic using Wireshark. Then we will learn basic of asymmetrical and symmetrical cryptography. And then we will talk an application in cryptocurrency. First, let's talk about internet eavesdropping. So your data, for example, your login information may pass through many devices before reaching its destination. For example, your bank server. And if your data isn't encrypted, it's exposed, meaning that anyone on the path can read and store your data. And this is called packet sniffing or eavesdropping. And tools like Wireshark can capture and inspect every packet in real time. Next, we will make a demo on how to capture unencrypted traffic. So to follow the demo, you will need first software Wireshark to capture and analyze network traffic. Then you need software VMware to simulate a local network environment with virtual machine. So, and you will need Ubuntu to install OS for each virtual machine. You also need to install Netcat in Ubuntu to send unencrypted data. Here is the diagram of your virtual local network created by VMware. You need to create 3 VM. They will be in the same virtual local network. The first VM is a sender who want to send a message, hello world. The third VM, the receiver want to receive the message from the sender. But then we also have a VM2, which is the attacker who install Wireshark on their virtual machine. So on the attacker side, then first we need to open Wireshark. In Wireshark, we need to listen on the local area network. And on the receiver side, we need to use Netcat to listen on a specific port. And in this example, listen on 1, 2, 3, 4. Moreover, we need to capture the IP address of the receiver. And on the sender, we will use Netcat to send the message hello world to the specific IP address that we already copied. Well, moreover, we need to specify on the port 1, 2, 3, 4. Now we check on the receiver side. So you will see that the receiver has received the message hello world. And on the attacker side, when we check Wireshark, we will filter out the port 1, 2, 3, 4. And we will look at the message. Then we will see the message hello world are captured. Next, we will talk how the current cryptography protect our data with symmetrical cryptography. So when Alice want to send a message to Bob like hello, then we assume that there are already a person who want to analyze and capture Alice. To do so, to protect the data, Alice and Bob need to share the same key to encode and decode her data. So the key thing in symmetrical cryptography is that Alice and Bob use the same key to encode and decode the data. So the first thing is that Alice and Bob share the key. Then Alice encode her data and send encrypted data to Bob. Finally, Bob receive the data and decode the encrypted data based on the key. There are several standards using this philosophy, which are AES, DES, or 3DES. But the problem is how to share the key in the beginning. That's come to asymmetrical cryptography. And in asymmetrical cryptography, we need a pair of keys which is public key and private key. So in this scheme, Bob will create a pair of public key and private key. The special things in this scheme is that um, to encrypt the data, so Alice will use public key, but only the person who hold the private keys is Bob can decrypt the data. So after Bob create a pair, Bob will send his public key to Alice. Then Alice encode her data and send to Bob. Bob receives the data and decrypt with the private key that he keep secret for himself. And there are many standards using this philosophy, for example, RSA or ECDH, but those asymmetrical cryptography standard will be broken when the quantum computer is powerful in the future using Shor algorithm. Next, we will talk an application of asymmetrical cryptography in cryptocurrency. Let's talk about a digital signature. So in cryptocurrency, the server need to verify a wallet owner with a transaction. For example, Alice want to send one Bitcoin to Bob, then she will send the transaction to the server. And how can the server verify that the transaction is belong to Alice's wallet? To do so, Alice will also need to create a pair of public key and private key. And she will use the private key to make her digital signature. And the public key will be her wallet address. So first, server create its public key and store Alice's public key as the wallet address. Next, Alice will create her signature based on the content of the transaction. For example, send one Bitcoin to Bob with her private key, and we will have a digital signature here. Next, Alice will encode a transaction. So a transaction will include the content as well as the digital signature. So she will encode the whole transaction into an encrypted data using the public key of the server. So remember that here we use the public key of the server. Then the server receive the encode data, and the server first will use its own private key to decrypt the encrypted data to see the transaction. After having the transaction, the server needs to validate whether the transaction is belong to the right wallet based on the wallet address, and use the wallet address with the content and with the digital signature. The server can answer that is it a correct wallet, correct transaction or not. Yeah. This is all information today related to data thief and cryptography. See you in the next video.